Hello guys, so today we are going to be going over combination sum Leet Code problem number 39. And in this problem, we have to use depth first search, like we covered in the last video. So a quick rundown of the problem is we get an array of candidates, and then we have to return every combination of those candidates that add up to the target. And the candidates can be used once over again, or as many times as you want over again. As you can see here, we have 2, 2, 3, even though we only have 2 one time. And in this one, we have 2, 3, 5, and one of the solutions is 2, 2, 2, 2. So this introduces some unique problems because it is difficult to keep track of where you are in the problem when you loop through the candidates. And it's hard to keep track of all the different variables and pointers that you need to. So now I'll be typing out the solution and talking about it as I go. So here is the outline of the problem. As you can see, we define result, which is what we will be returning in the end. And then we define a function right here, the DFS function, depth first search, and we're going to be calling this function in a recursive way, as you will see as we type more of the solution. So here are the scenarios where we would return and kind of jump out of the DFS function. We would jump out of the DFS function if temp target is less than 0, because we will be subtracting from temp target every single time, and if it reaches below 0, then we know it's not the right solution. Or if temp target is the right solution, then we pop out of DFS as well, but we push the path spread out into result. Alright, so here is the completed function, and as you can see, this is how recursion works. So we have the initial call of the DFS function, and then we have, in the DFS function, we call it again, and we just pass in different values into it. So as you can see, the temp target changes, and it will keep on subtracting candidates I until either it equals 0, or until it is less than 0, in which case we return both times, and in this case we add path to result. And we keep track of path by pushing candidates I into it as we go every single time. And finally, to backtrack, as I talked about in the previous video with depth first search, how when you run into a dead end or a previously visited node in a way, you backtrack by popping the top of the stack off. So path is a stack, and it follows the LIFO principle, last in, first out. So that's why we add it by pushing to the very top of it and popping from the top of it. We don't shift or unshift this array. Alright, so we'll run this, and as you can see, it's accepted across all of them, and now we will submit it, and as you can see, it passes all the tests. Alright, so now I'm going to show how the data flows, and I'll also talk about how in recursion there is sort of a snapshot or a context in a way of the local variables, and that's how we're able to reset the temp target or the target without explicitly going temp target equals target when it goes back to the start. We don't have to do any of that. We don't have to reset the iterator, and recursion takes care of all of that for us using the snapshot or context, as you'll see. So we're going to go over this first one right here and talk about all of the different steps illustrated in this Excel sheet. So you can see the different variables. So this is the step, this is the index, and this is the current candidate that it's on, and then the path variable and temp target. Alright, so we start with step 1, which is the current candidate is 2. Then we go to step 2, current candidate is still 2, and the path is now 2 because we pushed candidates I there. And the temp target is 5 because temp target turns into temp target minus candidates I, as you can see right there. And the iterator still doesn't change. And then we go here, another 2, subtract from temp target equals 3, subtract again with temp target, it equals 1, and now there are no valid steps, so then we backtrack. And how we backtrack is we go through, it's returned, there's no valid ones, so it would be less than 0. Path.pop it, and try another variable. And because we make it through this for loop, the iterator ticks up, so then we're on candidates I, but I is 1, so that is 3, and the path got popped, so it's just 2, 2. Temp target is 3, and the current candidate is 3, so then we have the valid combination is found, and it is added right there. So that would be this is added because that is equal to 7, it is equal to the target, and then we backtrack because it returns, breaks out of that, and then we're back to 2, 2. And the path gets popped, and then we go to the next variables, which are 6 and 7, which when you subtract those are both less than 0. We backtrack again, we test 3, it's 5, no valid steps. So then we backtrack again, and we test 2 with 6 and 7, still no valid steps, so we backtrack again. And now path is completely empty. Temp target is back to 7 because of the context and the snapshot sort of principle of recursion. So it goes back to the local variable of the very first one. So you can kind of think of there's a lot of functions running inside of each other, and once that function breaks out, then it returns to the local variables of that function of DFS before it went into the next function and the variables change. So when you pop out, you change the variables. As you can see, temp target gets bigger and bigger and bigger because we're like sort of undoing the local variable change right there. And now with path empty, temp target being 0, and now we start at 3. And with 3, the temp target is equal to 4. No valid steps, so then we backtrack. Then we backtrack again because no valid steps. Pop, change the local variables through the context or snapshot. Move to candidate 6. Temp target is 7. And then temp target is 1. And we test all the variables there. No valid steps again. And then the current candidate is 7. And we go through and we find that 7 being the target and the current candidate is a valid combination. So then we push it, and then we get our final result right there. And once all of the DFS functions are completed, so path is empty, and we make it through all of the for loops, all of the DFS functions, we break out of this initial DFS function, and we return the result, which, like I said right there, is that. And that is how the flow of the data works. I hope that context and snapshot principle of how the local variables change makes sense. And that is Leet Code question number 39, combination sum. I think I'm going to have a video coming out soon talking more in depth about recursion and how that works, and more in depth about the snapshot or context of the local variables. So look out for that in the future. Thanks for watching. Make sure to subscribe and like, and I'll see you next time.